So the next speaker is, who I'm very honored to introduce, is Piero Scaruffi, who will be talking about a brief history of artificial intelligence. And I'm going to give you a small version of his very large list of accomplishments, only because he's going to be mad at me for taking up too much time from his talk. Piero is a cultural historian who has lectured in 3 continents and has published several books on artificial intelligence and cognitive science. He pioneered internet applications in the early 1980s and the use of the World Wide Web for cultural purposes in the 1990s. His poetry has been awarded several national prizes in Italy and the USA. As a music historian, he's published 10 books. His latest book on AI is Intelligence is Not Artificial, and he's also written extensively about cinema and literature. He founded the Leonardo Art Science Evening Rendezvous in 2008, and of course, the last festival, Life, Art, Science, and Technology Festival in 2014. And since 2015, he's been commuting between California and China, where several of his books have been translated. Please give a warm welcome to the mastermind behind this whole entire festival, Piero Scaruffi.
Thank you. Thank you. So this is me, 1987. It's not Photoshop. And that was pretty much the beginning of the end. We're just coming out of a long winter of AI. So don't buy my book. Why? Because this is the old version. This is going to be the new version. Slightly bigger. Probably the first speaker you heard who tells you, don't buy my book. I will start with a 5-minute history of artificial intelligence. 40 slides, 5 minutes, just for those who are not familiar, although these days it's becoming so popular. Then I will focus more on the present, and then I want to say something about the concerns that people have about the future. If I have time, I would love to talk a little bit about AI in China. I've been spending 50% of my time in China in the last 2 years. Okay, so artificial intelligence starts a long way back, actually. There were, automata. You've seen some in the previous presentations. And actually, I found by accident this article in a magazine, 1934. They were asking, are thinking machines possible? I always like to show this picture when I start these presentations because it shows the computers as they were, the very first computers. And I love the fact that all the programmers were women. Why? Well, that's for another presentation. The very early articles and books, they all talked about the electronic brain. That's actually the first book on electronic computers. It was titled Giant Brains. So the idea predates all the stories that we have today. And of course, the movies, science fiction is always ahead. These movies dates from the 20s. There were some very important events, groups, conferences that happened. It's a fascinating story. You should read them. It was very interdisciplinary at the beginning. This is before the first computer is sold. An amazing group of people. And this was in Britain. Alan Turing is the most famous out there. Amazing group of people getting together to talk about machines. And then Turing in 1950 wrote the famous paper that Maya mentioned about the Turing test. 1951, I consider it, in a sense, the birth of artificial intelligence. It's when the first commercial computer comes out in England. And in Paris, there was this conference that is not much talked about in the United States. If it doesn't happen in the United States, it's not popular. So this happened in the United States. So there was a famous conference, actually workshop in 1956 at the MIT, organized by later famous scientists Marvin Minsky and John McCarthy. You probably heard this before. At the beginning, artificial intelligence had 2 main schools of thought. There was a school that said, let's simulate the way the mind thinks. And that led to a symbolic approach to artificial intelligence. If you heard the words knowledge-based systems, Hesper systems, that's the school. For a long time, there was the preeminent school. That's the vast majority of AI researchers were going to that school. The other school was neural networks. The idea was let's simulate the structure of the brain. Sounds like the same thing. Let's simulate the way the mind thinks. Let's weigh the structure of the brain. Actually, no. There's two different approaches. Of course, the goal is the same. And so that's neural networks, connectionism, and so forth. So for a while, the first school was prevalent. In fact, I found I have the proceedings. I'm that old of the ICHCAI International Conference on Artificial Intelligence, 1969. There were only 2 papers on neural networks. Why? Well, one simple reason was machines. Machines were not powerful enough for any of this, for any of the research that was going on, but especially to build neural networks. Anyway, so for a while they tried, and most they failed. AI didn't deliver, and unfortunately, some of the founders of AI overpromised. Now in the world, there are machines that think, that learn, and that create. That was said in 1957 by one of the founders. It was a little optimistic. So that eventually caused a backlash, and there was a problem, and so people like me lost their job because AI was not popular anymore. In fact, it was a bad word, and many of my friends removed from the resume that they had worked on AI. So I'm amazed to be here to be talking about AI in 2018. Anyway, so what changed? In my opinion, the big thing that changed is really Moore's law. Computers got faster and faster, cheaper and cheaper, smaller and smaller. They made a huge difference. A lot of the ideas that today cause sensation, if you read the papers, actually some of them are really old ideas. Now, today, most of what you see publicized is deep learning. And I just want, before I go further, I will be talking mostly about deep learning. But before I go further, I want to tell you there's a lot more. There's artificial intelligence, machine learning, which some could also say starts with statistics, goes all the way into AI. Then there's neural networks, then there's deep learning. There's a lot more. In fact, in the conference, 1956 conference, my personal hero is actually Ray Solomov, which nobody mentions anymore, but he had some great ideas on how to build artificial general intelligence, and it's totally outside that picture. For those who never seen a neural network, I doubt these days people haven't seen these things, but neural network looks like that. In the old days, just a 3-layer neural network was a major achievement, and today we can have multiple layers, so it looks more like that. Actually, neural networks, the algorithms to solve the problems of neural networks go back a long way. Again, if it's not done in the United States, it's not popularized. But in 1965, somebody in the Soviet Union, I believe it was in Ukraine, actually, today's Ukraine, had already solved the problem of having a neural network with many layers. So neural networks had 2 problems. One was just the machines were not powerful enough, not cheap enough. But the second one also, theoretically, you had to solve the problem of how to do computations on many layers. So somebody has solved the problem theoretically on paper in 1965. Then in 1979, somebody in Japan came up with the convolutional neural network. And from here on, I'm showing you the slides. I'm not discussing them. It would take a very long time. I want to pay attention to the fact that there's mathematics. There's formulas. These are the steps that led to today's deep learning. And I just want you to pay attention that there are formulas, and then I'll tell you why. So 1989, this is pretty important. LeCun does something to convolutional networks, makes them more interesting. LeNet 5 recognizes digits, the first really major application of neural networks. This is also important. Jürgen Schmidhuber, the first gentleman in that picture, found a way to give neural networks memory. That's pretty important. That led to machine translation, many other things that we have today. And at 6 p.m., I'll play a video of him to close this day. I just met him in Switzerland, and we taped our conversation. So neural networks were impractical until recently. In fact, the self-driving car, 1994 in Germany, yes, it's that old. But again, it's not made in the United States. It's not as famous. But 1994, the first self-driving car, IBM's Deep Blue, that beat the world champion of chess, even Watson and Siri, more recently, they were not using neural networks. It's just not that practical, okay? And then what happened? In 2006 and 2007, within a few months apart, Hinton and Banjo explained how to do it, how to do deep learning in a practical way so that it works. And again, I will not discuss it, but I want you to see that there's mathematics. That's what it is at the end of the day. So starting 2006, 2007, we knew how to do it, how to make it practical. And I should also mention Alex Graves in Switzerland, working with Schmidhuber, made LS team, did an improvement that made the whole thing practical. Okay, 2012, something important happens. Until then, nobody was really talking about this. But in 2012, some impressive result came out of this deep learning school. That's a yearly contest in which they measure neural networks' ability to recognize images. And as you see, it's been going down slowly, and then 2012 suddenly goes down quickly, and then it starts going down faster and faster. And now, starting 2015, the neural networks are better than humans at recognizing images. So that started in 2012, and everybody looked at who did it, and who did it was Hinton's group in Canada that was using deep learning. So everybody started paying attention, 2012. Now, I told you that he invented the technique in 2006. Why did it take until 2000? And by the way, it was an 8-layer network, which at the time, eight layers, oh my God. Why 2000? And 2012 is when you start having all the big announcements. If you heard of this Google Stanford system that recognizes cats on YouTube videos, 2012. Offline Chinese handwriting recognition, near human performance, Schmidhuber again, 2013. Speech recognition, the error rate goes down dramatically after 2012, and so on. Why 2012? I told that it was invented 2006 and then 2012. Well, it took two things. One, it took again, machines powerful enough. We have to thank the industry of video games. It turns out that because of video games, companies like NVIDIA were making GPUs, and GPUs are very fast processors, long story, but anyway, they're small and they're very fast, perfect for deep learning. And the second thing, neural network, as you probably learned by now, doesn't do anything unless you train it. Previous presenters kept talking about training the neural network. How do you train it? Data set. You need data sets, huge data sets. These are some of the historical ones. So that's why 2012, okay? Training data set and so on. So today, lots of business going on. Why I have this slide? I got tired of updating it. That's all the acquisitions by major corporations of AI startups. Well, if you pay attention, most of them start after 2012. Not a coincidence, okay? So trivia, I love trivia. We don't have time tonight. The stars of deep learning. I wrote down all the names you saw in the previous slides and the country where they were born and raised. Now, today, everybody thinks deep learning is a Silicon Valley thing, right? Google, Facebook, and so on. Not one born and raised in the United States, which is kind of interesting. That's how unpopular neural networks were in this country. And also pay tribute to women. This is actually a field where women are not as numerous as men, but it's getting there. A lot of the main ones are women. Okay, now coming to today, and again, big warning, we are focusing on deep learning, which is just one piece of AI. I wouldn't be surprised if 10 years from now I'm giving a presentation on AI and I'm not talking about deep learning, okay? Something happened, a few new ideas came out. Reinforcement learning is a very old idea. It was Marvin Minsky's thesis in 1951. But deep reinforcement learning is relatively new, and you're very familiar with it because it's being used to build machines that play Go, in Chinese Weiqi, and the most famous is AlphaGo. made by Google. When Google does it, everybody talks about it, right? But it was done before. And so there's a lot of things to say about this. Anyway, then AlphaGo was improved into AlphaGo 0, and then Alpha 0. AlphaGo 0 learned the rules of Go in 3 hours, and Alpha 0 learned also to play other games, including chess, at the superhuman level. So that's deep reinforcement learning. Obviously, it works. It needs time, but it plays against itself. It gets better and better and better and better, and eventually better than human beings. So that's one thing that's happening today. Another thing is happening today that recurrent neural networks have been improved, as I said, by this Swiss lab in particular, and by Google, and by others. And now they're used to predict what comes next. So machine translation is a typical case where you have to predict which word comes next. And Google implemented it in, I think, November 2016. And I think all of us who were using it noticed a dramatic improvement in that month as they shifted to this technology. Then somebody realized that recognizing a scene, recognizing what is going on here, young people playing Frisbee, that's a form of translation, actually. And so they applied it to recognize what is going on in a scene. It's pretty much the same. It's a little more complicated, but the same idea. And then Google in November 2014 posted this impressive thing on its blog where there's all these images, and that's written by the machine. The machine understood that young people are playing Frisbee. Machine recognized 2 dogs playing in the grass, well, 3 dogs, but it's good enough, right? Now, so that was very impressive. But I want you to focus on this one. That was there. It was in the second row. And nobody ever mentions this one. And actually, that is a street sign and was recognized as a refrigerator filled with food. And so that was a mistake, right? Now, another new thing, I think Steve mentioned it before. Anyway, generative adversarial networks. Why they developed them to improve the way neural networks learn. But in particular, they do something interesting. They generate a picture. See, you can't just recognize a dog. You can also draw the picture of a dog. That doesn't exist. That means you know what the dog is, right? So Ian Goodfellow invented this new kind of neural network. And then this paper appeared that caught our attention. These images are not real objects. These objects have been generated by the neural network. And they look like real furniture, but they're not. So that was impressive. And then somebody realized you can use this technology to turn text into pictures. So you write flower, and the neural network generates the image of a flower. And initially, this was kind of trivial, but then somebody realized, if I can do that, I can write down the script of a movie, and then the neural network will generate the images. And that was done. That was done. So you write down the text of your movie, and the neural network will generate the video. So the future of Hollywood is there, maybe. It can't get any worse than it is, right? And then more, Steve Omohundro had these images in a better resolution. But anyway, then the same technology has been used to turn zebras into horses in the videos, and then turning images. Like once the neural network learns what it means to have a summer picture, it can turn a winter image into a summer image, and the sunny image into a rainy image. Okay? So it has learned what that means, what it means to be rainy or whatever. Or a brunette into a blonde, and so on. Okay, now, the other thing that is happening right now is very deep learning, many, many layers. As I said, 3 layers used to be a lot. 8, AlexNet in 2012, oh my God. There's different theories if that's good or bad. Some scientists actually think that you don't necessarily gain a lot by having more layers. But anyway, that's a trend. That's clearly a trend. I'll show just the images of some of these. That's the one in 2012 that made deep learning popular. It was 8 layers. And then you have VGGNet, which I assume had 16 layers originally. I think then the paper had 19 layers. And then GoogleNet, also called Inception, went to 22 layers. And in some cases, it's just having many layers that can do many things. But in some cases, the layers get different. So here, Google is using a kind of module called Inception that is simpler, but somehow seems to work better. And then we got to ResNet a couple of years ago from Microsoft, 152 layers. And does that give us better results? Well, it looks like. It looks like so AlexNet is 8 layers. VGGNet was 19, GoogleNet 22, no, VGGNet 19, and ResNet 152. So other people disagree and think that actually maybe they should focus more on the quality of each layer. Anyway, that's been, as you saw in Steve Omohundro's presentation, there's some overlap here. Now you can do things like this. You know, this is face-to-face. It's interesting that he credited it to Google, right? I credit it to Matthias Nissner in Germany. In my opinion, he's the one who wrote the paper on this thing. Anyway, that's the source. That's, I assume, a student who is making that face. And the video, the original picture in the video was that one. But you see what happens to the video. And so you can have the whole video where you make faces and you are altering the video as Schwarzenegger making the faces that you are making. And then from there we went to, Peter Cushing was resurrected in Star Wars. Some of you may have watched this horrible Hollywood movie. And so he's there, he's playing 20 plus years after being dead. And it was done by Paul DeBevec at University of South California. And Steve also mentioned these programs that allow to do similar things with voice, alters what make people say things that they never said. And he mentioned also deepfakes, where you put the face of your favorite erotic star on your favorite Hollywood actress face on a video, on erotic video. And this has been taken down by Reddit January this year. Okay, so given all of this, of course, some people get alarmed. Some people think that we'll all be resurrected very soon. So some very intelligent people actually are worried about this. People much more intelligent than me. So reality check. I always start with the image of the #1 robot 2017, which is a vacuum cleaner. So whatever is coming next, I don't think it's coming very soon. Reality check. So first of all, the neuron. When we talk about neural networks, these are artificial neural networks, okay? That's the neural network. That's the neuron in a neural network. Today it's a little more complicated, but it's still fundamentally a formula. That's your neuron. Your neuron is very complicated. We don't even know how it really works. There are more than 70 types of neurons. No two neurons are alike. There's 50 plus kind of neurotransmitters and so on. So just physically, there's a big difference. Second, machines do impressive things. But people should always tell you how they structure the environment for the machine. Machines can do amazing things in a controlled environment. Of course, factories are mostly automated these days. But we structure the factory for the robots in that place. And assuming that there are still self-driving cars driving right now, after somebody died, they depend on the important things in this picture is not this, it's this. Somebody has made the lanes. Somebody has put the traffic light, the street signs, and so on. Somebody has structured the environment for the machine. Recognizing a cat is very impressive, but let's not forget that any mouse recognizes a cat without the need of 16,000 computers working in parallel at Google search. AlphaGo, very impressive, no question. Nobody expected machines to play Go that well so soon. But I did a little calculation based on DeepMind's paper. That machine consumed 440,000 watts. To do what? One thing, play Go. Now, my brain, your brain, very humble, 20 watts. I can play Go if I want. I get bored if I keep playing Go like AlphaGo does. I can play Go. I can speak to you right now. I can cross the street. I can go upstairs, buy a sandwich. You can do an infinite number of things with 20 watts. So very impressive, but there's something wrong there if you're really trying to simulate and beat the human brain. That's a 20-watt machine of 1915. Okay, the other thing, machines can do impressive things. Neural networks can do impressive things, but don't forget, they need to be trained. Somebody has built a huge database. Most in red, you see some of the news about AI achievements. In blue, it's the data set that was used. There's a data set, a few years later, there's a major achievement by neural network. There's a data set and so on. 2013, Michael Bowling built a data set of Atari games. 2015, DeepMind showed a neural network that can play those video games better than us. Okay, so there's a data set. Somebody has to build a data set. That's why the real news in AlphaGo wasn't really AlphaGo that learned from a million whatever human games. It was more like AlphaGo 0 and AlphaZero. I have a long article on my website about those systems. And some of the achievements that we see today are based on old ideas. There's nothing wrong with using old ideas, but it's just to be aware that the progress we see, again, is mostly more slow. This is not me saying it. I assume you know OpenAI is the research center founded by Elon Musk. Is doing a lot of interesting research, and they said on their blog, this thing is based on something known for decades, not just for 2 or 3 years. Okay, so some of these ideas are old ideas that today we can finally implement. So it depends how you define progress. If you consider progress just based on the results, yes, there is a lot of progress. Intellectually speaking, a little less. Now, limitations. This is very important. This is a dog, and that's a dog for us, not for the neural network. Okay? This was a paper published in 2013 where they showed that all you have to do is manipulate this image with these pixels, and you obtain this image. There's no difference, right? There's no difference for the human eye. For the neural network, there was. And they didn't recognize it as a dog. And even worse, those things, this was 2015, some of those, I don't know how to define them, abstract patterns were recognized as a panda, as a worm, a penguin, and so on, with a certainty of 99%. Okay? And in fact, somebody built this, I think it was 2 years ago, 2016, built Deep Fool, a simple and accurate method to fool deep neural networks. And so it didn't come as a surprise to me that people are getting killed. You know, this is, for those of you who missed it, just happened. And in chatbots, another long story. I didn't have here the whole story. Microsoft had to take down its chatbot because it started saying racist things. And I just did this now. You can do it. And I was looking for Saint Augustine, which is a philosopher famous for writing about time. So I entered Augustine, what is time? That's what I got, pizzas. So, and robots, there's a lot of videos where you see robots doing amazing things. First of all, you should always check the speed, because at the bottom of the video, it says 20 times or something like that, and you see the robot doing this. What the robot is really doing is this. Okay, so. But also, one of the famous videos was from Google, and that, as far as I know, that project has been canceled with no explanation. Security robot at Stanford ran over a toddler, and so on. So the worst part, so my reality check is, yes, there's progress, but I mean, there's one thing missing in these machines. There's one very important thing missing in machines. This, common sense. So why Google made that mistake? A refrigerator filled with food. It doesn't have common sense. You could easily make a mistake. I can easily think that that person is John. No, that's not John, actually. That's a That's a legitimate mistake. It is a person. It looks like John. It dresses the way John normally dresses. It's a legitimate mistake. This is not. And a self-driving car confuses a pillow for a child or a child for a pillow. That's not a legitimate mistake. Okay, so common sense is very important. My definition of common sense, this was a real story. April 2016, these children formed an arrow on the ground. Why? Because a police helicopter was chasing thieves, some criminals. I don't know what they had done. The children improvised this thing. Now, why? These were children. Nobody told them to do it, okay? Well, you have to be a human being to understand. A, police good, criminals bad, usually. In some places, but usually, police good, criminals bad. And but helicopter will not hear me if I tell them. So what can I do that the helicopter, to communicate with the helicopter? I can show things, they can see me. What is a sign that they will understand? Arrow, okay? Common sense. Those 12-year-old children had common sense. Boston Marathon attack. Do you know how they caught the terrorist? They watched the humans, that's before we had automatic scanning of machines. They watched all this footage of the Boston Marathon. They saw the bomb goes off and they saw all these people freaking out, running, screaming, except 2 people who were walking like this. What does it mean to you? Those 2 people knew that there had been a bomb. They knew that there wasn't another bomb, but they were just walking away. So if you use common sense, you capture these things. Machines don't have common sense right now, okay? So that's important. This is also funny. Last year, June 21st, the Los Angeles Times website announced an earthquake that just happened in 2025. It was a glitch in the computer, the USGS. Most news media received this cable, whatever it is now, email from USGS saying 2025. They picked up the phone, old-fashioned people, called and said, it's a glitch. Okay, bye-bye, click. But they were more advanced. They have a bot that automatically produces the news. And so for a few hours, the Los Angeles Times website had the news that there had just been an earthquake in 2025. Now, probably I'll be around. If on the 21st of June 2025 there is an earthquake in Los Angeles, we're in Nostradamus area. Okay, now, some of the things that Maya said about intelligence, I really like them. No human intelligence has always been around. Now, is it superhuman or subhuman? Well, it depends. If you're human, you think everybody else is lower. But think of the bat. Bat is one of my favorite animals. It can fly in the dark. Can you fly in the dark? It can capture insects in the dark. It flies very fast, avoid obstacles. It even lands upside down on the ceiling. Can you do that? So no human intelligence has always existed. And we built a lot of artificial intelligence. The clock was invented about 1,000 years ago, and it keeps time. Nobody in this room can tell me how many minutes and seconds I've been speaking, but this clock can. By the way, I only have 10 minutes, huh? No? So that's superhuman intelligence, okay? So now, last 10 minutes, but 10 minutes including questions? I have to finish now? Okay. Do robots steal your jobs? I don't think so. If you look at the density of robots in the world and unemployment, the countries with the highest density have the lower unemployment. Not my fault. I'm not an economist. I just don't see it. These machines have stolen millions of jobs, but I haven't seen panic among traffic guards. I was in China in a subway. I took these pictures. There's machines selling tickets, machines selling food, machines taking photos. Then when I go to the actual subway, there's a machine checking my luggage and a machine checking your ticket. In the old days, this picture of China would have shown millions of people elbowing and officials checking this and that. It's all automated. As far as I know, there's no massive unemployment in China. So you are already surrounded by machines. Okay? Somebody's building the machines, somebody's maintaining them. I think they're creating a lot of jobs. When I go to China, I take this robot. This is the most complex robot in the world. It's called Airplane. And it does an amazing thing. It flies. So in my opinion, it will create new jobs. The real question is which jobs will be created. That's where discussion becomes really serious. Which jobs will be created? Now, these are the formulas I showed you at the beginning. So if you can read these formulas, you have a highly paid job at Facebook tomorrow morning. If you cannot read any of these formulas, maybe you have a problem. Okay, so we need AI soon. Why? Because there's a lot of interesting applications. And my favorite is this one. Image recognition. There's a lot of images, medical images out there. And today, neural networks can use those images to predict the chances that you have a major disease and prevent it. So they can save millions of lives. People ask me, what is the next breakthrough? In my opinion, we underestimate the importance of these government programs. I know today it's not popular to talk about big government. But the Apollo program, the ARPANET, the Human Genome Project were very important for science in general, for scientific progress. And so today there's this international and national projects, and in my opinion, that's going to be very important for the future. Okay, I think I can stop here. AI in China, we'll do it some other time.
Okay, we have 9 minutes for questions.